So this video series here will be divided up into two segments. The first will cover Newton's first and second laws, and the second video will discuss his third law. So Newton essentially split the same general idea into two laws, his first and second. So the first law states that an object at rest tends to stay at rest, and an object in motion tends to stay at a constant speed and in a straight line unless acted on by an unbalanced force. So we can simplify that. This whole part here is important to recognize, right? But we're going to hold off on discussing that for a second. So objects at rest tend to stay at rest, and objects in motion tend to stay in motion. So the object at rest, for instance, this example here talks about a chair. That chair doesn't just start sliding across the floor all of a sudden. It takes an unbalanced force in order to change its motion. It means that you or I need to go over and push that chair for it to start moving. Now, in contrast, an object in motion is going to continue flying through the air or sliding across the floor unless something else acts on it. That something else might be gravity, that something else might be friction, or that golf ball hitting a wall, or somebody catching it, or it hitting the water because of gravity pulling it down. So that's why friction and gravity here are called out as being generally the two sources of unbalanced force. Right? It could also be it hitting something or somebody catching it or something like that. But friction and gravity are the universal forces that stop motion, that provide the unbalanced force. So now this whole thing about at a constant speed and in a straight line. If I push the chair, the only reason the chair's path is going to curve is if something else is causing it to curve. If the floor is tilted and gravity's acting on it and it causes it to slide or roll, whatever we're talking about, in kind of a curved path. It would also continue at a constant speed. It wouldn't accelerate constantly because of what force? Gravity. Friction rather. Because of friction or air resistance, it's not going to continue to accelerate and accelerate. It'll travel at that constant speed. Well, at least until friction acts on it more and slows it down. So this idea down here, inertia, it says the tendency of all objects to resist changes in motion. So that golf ball that's flying through the air, it resists a change to its motion that would be otherwise caused by gravity. That chair that is sitting there not moving, it resists moving, and the reason for that is because of inertia. Another word for inertia is mass. So the more mass an object has, the harder it is to change its motion. We've known that forever. You've known that since you were 3 years old. You push a very light object, it moves very easily. You push a very heavy object, it's harder to start moving. So that idea of how easy or hard it is to start or stop its motion is called inertia. So let's just remember that inertia is really just the concept for mass, for how heavy an object is. So the softball versus a bowling ball. The softball is lighter than the bowling ball. It's therefore easier to throw or to stop, right, to catch, than would be a bowling ball. The bowling ball has more inertia. It has more mass. So that's Newton's first law. Newton's second law, we can go through all of this right here. But what it is really saying is this. If you increase the mass of an object, the acceleration will go down, assuming the force stays consistent. So you increase the mass, the acceleration is going to go down. You decrease the mass, and the acceleration can go up, right? Assuming force stays the same in both instances. In the other side of things, if we increase force, what's going to happen to acceleration? It's going to go up. If we decrease force, acceleration is going to go down. This is nothing new. We've been studying force and friction for a while, and we know that bigger forces cause more acceleration or deceleration. Smaller forces cause less acceleration. And we also know that, just like discussed in law number 1, heavier objects, more massive objects, objects with more inertia, are harder to accelerate. So that's really all this law is saying here. Acceleration depends on mass. It's easier to accelerate an object with a small mass than a large mass, right? Trying to move a 400-pound object versus a 100-pound object. Also, acceleration depends on force. If you increase the force, the acceleration increases. That makes sense. What this diagram here is showing is the idea that all objects accelerate at the same rate due to gravity when they are in free fall. So here we've got a watermelon with a mass of 1.02 kilograms. The force due to gravity pulling down on this object is 10. If we set up our equation, 10 newtons equals 10 kilograms, and we're solving for meters per second squared, do the math out, we get 9.8. They ran calculations on the apple. An apple being 0.102 kilograms, the force is actually only 1 newton. See that there's a difference in a factor of 10, a difference in factor of 10. Do the math out again. Rate of acceleration due to gravity equals 9.8 meters per second squared. Remember in our class, we just call that 10 for the sake of simplicity. So those are the first two laws. I'm going to pause and not go over the third law in this video, just because it's a little bit more nuanced. It's a little bit more detail that I want to separate out. There we go. So we'll go over the third law in the next video.